everyone, welcome back to another painful legal question. Today we're gonna work on one of the blind 75 question. Top k frequency elements. So given an array of num and the integer k, return k most frequent element. So you basically can return any order. Let's look at one of the example that is given. So we have an array of 6 elements, which is the top 2 because k equal to 2. See the result. Output would be for 1, the frequency is 3. For 2, the frequency is 2. And for 3, frequency is 1. So basically, because it showed up the most frequent, then our answer would be 1 and 2. So our output will be 1 and 2. Because we look at the frequency, so what is our solution? Because I'm reading in Python, so we'll be able to have a counter to calculate the frequency. And then, because we need to take top k frequent elements, that is when we think of a short algorithm. So that we use, this is one of the brute force that you can begin with. So right now, if we look at the time complexity, because we have a counter for frequency for the element, this take O of n to take the time. And then when you do need to short, the time complexity usually take O log n, which to extract the top element as well. And what is the space complexity? Would be O of n to store the count. Look at the question. So sometimes the question asks us for the optimization. The algorithm complexity must be better than O n log n. So another solutions to this problem will be using a heap, because right at the batch we need to calculate the frequency of the counter. So whether we use heap or not, the time complexity has to be O of n. And now the second step, instead of using short, we're gonna use a more optimizing way. For the time complexities of the heap will be, if it is psi k, our time complexity would be OK log k. And then we extract the top element, will be OK log k. It will become O of n plus k log k. More optimized than using short. So why do we need to use heap instead of shorting? So because we are working on a top frequent element, for several reasons, is usually for shorting, the time complexity is O of n log n, whereas n is the numbers of elements. However, like when you use the heap, and especially like when you use the max heap, you can do a partial shorting. Is that you don't have to short all the way through the n, but you only short k, which usually k is usually smaller than n, because like the element is 1, 1, 2, 3, but then n can be like 4, but then k you usually is smaller, is k equal to 2, so it's obviously more time efficient. And another reason why we want to use a heap is allowed for the early termination. So when we hit the order of the requirement, we can stop the process as long as you find it. So you don't have to like do the whole array. Save time. And then the space efficiency, like when you sort the entire array, you need additional space to store the short elements. Our number is 111223. So we will start by checking the frequency. So the frequency, we just return a dictionary. This is key value. And the key is actually our value of our element. We will have 1, 2, 3. What is the frequency of 1? Will be 3. Frequency of 2 will be 2. And then frequency of 3 will be 1. So that is how we start our frequency. So now we need a heap. We can heapify the frequencies of this array. So our max heap will obviously start with the highest frequency. Will be 3 and 1. So be careful, this is frequency and it's just a value because we matter the frequency more than the value, so I just make it more obvious. So next point, we will have, that is the maximum frequency, and then second frequency we will have 2, which has value up to. This one we will have value of, the frequency is 1 and the frequency for value 3. Yeah, it's a little bit confusing given the numbers and everything. So this is the frequency. I'm just not gonna circle it so it's easier to follow. And because it's the max, so this is 2 answer that we want to get. Okay, what is a heap basically? So the heap is starting with an array, and then you're gonna push all of the elements inside using heap push. So for Python, we will initialize the array. Start with an array. And then in order to push in the element, we're gonna do a heap push. So what is the formula for heap push? So the first one is the name of the array that we're gonna push right here. So heap. I'm just gonna do a max heap here so we can easy to and then what is the element that we want to add it in? So because this is a key pair value in the frequency, we want to add the frequency and the numbers in. And because this is a max heap, we need to have a negative before the frequency so that we always have a negative value to build a max heap. If you want to build a min heap, you don't need a negative value here for the frequency. Okay. So then, after we have the heap, imagine like this is the ball that have the heap inside. You're gonna pop the top 2. To get the most frequency of k equal to 2. Then you will have the answer. Okay, so this is a visualization, and now we move to the code base. So in Python, sometimes like the editor don't have the function, so you have to import heap and then import collection. You need to import the counter. I'm pretty sure in Leetcode you can just only collection.counter. So right now I just gonna initialize the count as a dictionary using counter. Think 1 second what you need to add it in. Then we just hit to add in the array that we're testing, which is num. And then we are building the max heap. So we need to initialize the max heap. We gonna use a for loop for the numbers and the frequency in the counter. So to get a key value in a count, you need dot, do you remember it? Items. And then you're gonna push it to the heap. Okay. Where you're gonna put it, you're gonna push to the max heap and the element. So in this way, our element we add into element is one is the frequency, another is a num, because we wanna get the most frequency, right? So we just cannot get the frequency before the num. So it's a little bit, be careful right here because easy to misunderstanding the numbers and the frequency because they are so similar to each other. And once again, for max heap, you need a minus values right here. Then we're gonna have a result, initialize the result where we need to return it. Okay. Then we have to loop through our heap. Okay, so what we want to do is we want to pop out the first two key elements. We're gonna do a heap. Then we're gonna pop, heap, pop. Our max heap element. And then we're gonna append that into our result. So right here, we already have our solution. Summarize again what is the time complexity, because we need to store the max heap. With the size of k. Okay,